So yesterday we were talking about functions. We talked about our input and output, our domain and our range. We talked about how to determine if it's a function. There's no hard and fast, like, always do this and look for that. You need to think about the inputs and the outputs. Visually, if you can draw the graph, you can do what's called a vertical line test. We talked about things that cause the domain to blow up. So things that are not included in our domain. When we take the square root of a negative or when we divide by 0. Those are the big ones, so we're always looking for that. And then we did some function operations. So we had f of x and g of x, and we add, subtract, multiply, divide. And then we did this nifty one where you did g of x plus 3 and you plug in. So that's where we left off. We have, I think, 2 more examples today with the f and g. So we're going to find each of the following and state the domain. I want to point out that yesterday I wrote it as f of x minus g of x, which is pretty intuitive, right? Like that makes sense. I just replaced f with what it equals and then I subtracted. The way that they show it today, and this is a proper notation, so it should, oh sorry, there is a teeny tiny typo. It should have had an x right here. So it is proper to do f minus g in parentheses and then the x. It's the same thing as f of x minus g of x. It's just a different way of showing the notation. Okay? So I wanted to make sure you had seen both of those notations. And I also want to point out, this is a teeny tiny dot. It is not the letter O. In a couple chapters, you're going to learn how to do something called f of g of x. Looks like the word fog. And that is different than the dot. So just be aware that that's not the same thing. Okay, here we go. So here's my f. My f of x is x plus 4. And my g of x is x squared minus 9. So when I'm subtracting them, I have x plus 4 minus x squared minus 9. I have to distribute the negative. So I get negative x squared plus positive x, and then positive 4 minus a negative turns into plus 9 is 13. So h of x is negative x squared plus x plus 13. Questions? All right, now we'll do a multiplication. So for the multiplication, we have to use our parentheses. X plus 4 times x squared minus 9. We're going to FOIL this out. First outers, inners, last. So my firsts are x to the third. My inners are 4x squared. My outers are negative 9x. And my lasts are negative 4 times 9? 36. I went a little out of FOIL order so that my polynomial would come out in the right order. Okay? This is division. Look carefully at the symbol. This is division. So f of x divided by g of x is going to be x plus 4 divided by x squared minus 9. Oh my goodness, you guys, I made the same mistake today that I made yesterday. Do you remember my mistake yesterday? Yeah. I forgot to find all the domains. Let's go back and fix it. Oh my goodness. Polynomials. We can plug in any real number. There are no restrictions. So the domain for this one is all reals. And you can use the double bar R. This second one was also a polynomial. And the other technique, if you want, you can use interval notation. Negative infinity to infinity is all real numbers. The division, not so much. So for this one, I have to pay attention to when I'm breaking the rules. So the rule is I'm not allowed to divide by 0, which means that x squared minus 9 is not allowed to equal 0. Which means that x is not allowed to equal positive or negative 3. I skipped some steps there. Are you guys okay with that? Okay. So my domain I've got some choices. I'm going to show you both techniques. I can say all reals where x does not equal positive or negative 3. That was my personal favorite when I was a student. You can think about interval notation. So negative infinity to infinity. Here's negative 3. Here's positive 3. It's going to be all of this. Skip that one. Skip that one. And then all of this. So that would mean if we wanted to do interval notation, we would have negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. 3 different chunks for the domain. Whew. If the problem says state your answer in interval notation, you have to do that. Sorry. It doesn't say that in the homework. Yeah. Usually on the test, I just say tell me domain and I'll take it either way, but. All right, you ready for number 4? Okay, you try number 4 without me. See how we do. If you need help, look at the screen. How'd we do? Okay, last one. So we're doing h of x is g of a minus 2. Okay, so this is what I do. I take g and I copy it down, and instead of x, I'm going to put parentheses. So I'm supposed to be doing x squared minus 9, but instead of x, I'm putting a minus 2. Which means I'm going to have to FOIL that out into a squared minus 4a plus 4 minus 9. So h of x equals a squared minus 4a minus 5. The notation's a little weird because we've got x's and a's, but technically we did what they asked us to do. Questions? We can't really do a domain or range on this one because we don't have any x's on that, and we don't know what a is. So we're going to skip domain and range on that one. I would not ask you to state domain and range on a problem like number 5. It should have had new instructions. Just evaluate. I won't ask you to do domain and range on that one. And if you notice, I haven't asked you about range because range, the output, the y values, way trickier than input, the x values. Because depending on what you get, sometimes you have to know more about the graph because sometimes it doesn't come out to be all reals. So it gets funky. Okay, so these are just some other examples asking you to use H and G and F to evaluate some stuff. So a little bit extra practice. I'm going to have you guys try these with your team, and we will regroup in 2 or 3 minutes. I'm going to stop the video. If you want to see the answers to this, they will be posted in Schoology.